I'm going to start.
I'm
there
so
we
sorry.
go.
I always forget. I'm sorry.
It's not official until Ms. Coco starts the recording. So my name is Marilise Barnard, and I'm going to be your teacher for this evening and for this course. This course is on the foundations of functions and inverses. So we really spend quite a bit of time going over the stuff from grade 11 that you might have missed due to all the disruptions because of the pandemic and everything that was going on. Or maybe, you know, your school was very organized and you were able to have lessons anyway, but you still want to have another look at it. That's what the foundations courses are for. We are really here to make sure that you have a solid understanding of the basic concepts of functions and trigonometry, analytical, all the different topics, so that you can really tackle the sort of routine questions in the paper and really maximize your marks in those areas before you carry on and maybe tackle some of the more challenging stuff. So up to now, this is our fourth lesson in this topic. We've done parabola, we did hyperbola on Tuesday. We sketched hyperbola, and tonight we're going to find the equation of the hyperbola, and we are then going to also do the exponential, because once we've done all four and we revisited all four functions, we can start with the inverses. So just a note, where is my announcement here? I don't want to forget to show you this. Let me just get the right page. We are having holiday lessons throughout the June holiday. So stay put. If you want to catch up, if you want to do some extra revision, if you want to just you know, really be ready, because it's not long before you write that September exam again. So we will be here. Don't worry, we've got you. We are going to carry on teaching and revising, and make sure that you are ready with your prep as you approach that important prelim exam and then that big final at the end of the year. Remember, maths is very much a cumulative subject where if you keep at it, if you persevere, if you just work every day a little bit, you are going to get there. I promise you that. Okay, it's like eating an elephant. Hey, Ms. Coco, what do they say? Eating an elephant, one bite at a time. I always feel a bit grossed out by that.
If the elephant is tasty, we just go with it. I mean, I'm kidding. I'm not advocating.
Maybe it can be like a giant Lindt chocolate elephant. We can eat it one bite at a time.
Yeah.
But anyway, that's how we do it, little bits at a time. Okay, so for those who are new and for those who might have forgotten since Tuesday, we have some house rules. Our house rules are quite simple. Please remain on mute so that we can keep the quiet of the room and not disturb people as they're trying to think and make sense of the mathematics. Also, if you do have a question, raise your hand like you would in a normal classroom, either through your emoji in Zoom or in the chat, or you can also DM Ms. Coco. Ms. Coco is our lovely TA, our teaching assistant, and she is always there to assist if you need support with any technical issues as well, or if you want to ask a question. Please use the chat for asking questions and posting your answers as we go through our lesson this evening. This is an active lesson, so you need your pen, your paper, your calculator, everything ready to do maths. Okay, maths is a doing activity. It doesn't help to just sit and listen. You have to get stuck in. You have to get your hands dirty and work through everything. Don't be scared to try. It is only through making mistakes that we really learn. So I really challenge you this evening to give it a go, even if it's hard or difficult, or if you think that you're going to get it wrong. Doesn't matter. Just give it a proper go. Okay. Please also in the chat, do not exchange any information with each other or engage in any chat with each other. We are really just here for having a great time and being together doing some mathematics. Okay, so having said that, Ms. Coco, I don't think I've forgotten anything this time. I hope I've welcomed all the newbies and I've explained the house rules, and now it's just on to the maths, I guess. Oh, tonight is quiz night. Tonight is quiz night. Yeah. I do apologize for the little bit of noise in the background. That is my puppy. As always, she's here with Watobe doing maths, and she's chewing on something. She's always chewing. But if you hear some noise in the background, that's her, my puppy, just being busy. She's grown up in Watobe since I got her, so she's been around ever since. She's in all the recordings, I think. Yeah, so speaking of recordings, if you have not been around for the last few lessons or you missed a lesson, please head over to the website and get the recordings for all the lessons there. Yes, she's very much a mathematician puppy. The recordings are available for all of our lessons, all of our topics. Please go have a look over there. Our quizzes are available as well. They are available even if the lessons have passed, okay? So you can still go and do your quiz. Speaking of quizzes, it is a low stress quiz. So tonight we're just gonna do a quiz on everything we've learned so far about hyperbola and exponential, and it's really just there for you to check your progress and for me to check your progress and to see how you are understanding these very important concepts. Okay, now remember, functions, it's about 30 to 40 marks in your paper one, so super important part of the paper. So I'll just quickly do a recap of what we did on Tuesday. We drew the hyperbola. The hyperbola is the function where we have x in the denominator. It's got two asymptotes, a vertical asymptote and a horizontal asymptote. And we also draw the hyperbola. The hyperbola goes over two quadrants. So it's got a part in either the first and the third quadrant or the second and the fourth quadrant. And if you remember, that is determined by the value of a. Our vertical asymptote we get from the equation. The vertical asymptote also shows our vertical shift, how the hyperbola has been shifted up or down. If we are subtracting in the denominator from the x's, that gives us our vertical asymptote, and our horizontal asymptote shows our shift up and down. And our vertical asymptote we can tell from the equation in the denominator whatever we are adding or subtracting, or what is going to make the numerator 0. Okay, so we went through the whole process of sketching, and now tonight we are going to do it the other way around. Given the sketch, how do I find the equation of the hyperbola? So always start, if you have your function, always start by writing down what it is that you are determining. You are determining the equation of the hyperbola. So you write down y is a over x minus p plus q. Okay, this is the general form of the hyperbola. So write that down, because that's how you're going to know which of the variables you still need to solve for. Okay, so you'll remember that a can be a positive or a negative number. Q is our asymptote, our horizontal asymptote, and P is our vertical asymptote. And that we can normally tell from the sketch, okay? The other thing that we are then going to have to solve for, once we have put the asymptote values in, is for A, and that we normally do by substituting in any of the other points that's been given. Okay, so I put down a few notes here. If you're given the asymptotes in another point, substitute the asymptotes, substitute the other point, write and simplify your final equation. Those points you can take down, but here is an example. Okay, so find the equation of the following graph. So it's always important to identify the correct graph. Okay, the question won't always tell you what kind of a graph it is. You must know the 4 different graphs. You must be able to tell them apart. Okay, so we can see that this is a graph that is in 2 quadrants. It's got these 2 asymptotes. Remember from Tuesday, the hyperbola is the only graph with 2 asymptotes. The exponential graph only has 1 asymptote. So that's another way that you can identify it by its shape, the fact that it's in 2 quadrants, and that it's got these 2 asymptotes. Okay, so like I said, let's start by writing down what it is we are trying to find. We are trying to find the equation of this hyperbola. So once you've looked at the graph and you identified it, then you must write down the general form or the equation of that graph that you're trying to find. Okay, and then we're going to substitute in our asymptotes. We've got an asymptote at y equal to 1 and another asymptote at x equal to -1. So we're going to put those in. We see the asymptotes right over here. So there's my vertical asymptote that I've substituted in. And for Q, I'm going to substitute in the +1. That is my horizontal asymptote that comes from here. So now I've got y is x +1 +1. We need to solve for a, so we are going to substitute in our point. And I want everyone to try that now. Sub in the point and then solve for a. Post your answers in the chat as soon as you are ready. Okay, we sub in. I hope to see some answers in the chat fairly soon. Okay, some say A is 2, some say A is 3, some say A is -3. Let's see what it is. Okay, I'm going to take the -1 over to the other side to get A over 3, and then times by 3, that gives me A is -3. There we go. I hope we're all awake now. Check that you did it correctly and that you got A is equal to -3. We get that just by subbing in, making y 0, x is 2. We have A over 3. We take the +1 over to the other side. That's a -1. And that's A over 3. And then to get A by itself, we times by 3 on both sides. So then A is -3. Great stuff. Okay. So I'm going to go right ahead because that really is all there is to it for the hyperbola. Okay, just subbing in your asymptotes and subbing in another point to solve for A. So I'm going to move us right ahead to the exponential graph. Before we can, then we're going to actually be able to get to some exam questions. So let's revisit this exponential graph quickly, and then we can get to some really meaty questions from past exams. Okay, so what have we got? As always, let's revise some of the basic ideas around the exponential graph. The exponential graph has x in the exponent. That's why we call it the exponential graph. Okay, so our input value is an exponent, and our output value, which is y, will just be a normal number. But it is important in terms of that whole thing of being able to identify what graph you have. It's important to recognize it by the fact that it's got x in the exponent. Okay, so our exponential graph can be two shapes. Either it is increasing, and I like to think of it as a plane taking off, or it is decreasing, and I like to think of that as a plane landing. That's the shape that it makes. So it all depends on the base. So if the base of our exponent is greater than 1, so if it's a 2, a 3, a 5, etc., then the shape of the graph will be a plane taking off or an increasing graph. If our base of the base of the exponent is like a half or a third, any fraction, then the graph is a decreasing graph, this plane landing shape. So here's an example of f of x is 2 to the power of x, and we can see quite clearly that that's an increasing graph. And now we can shift this graph left and right, up and down. So as always, if we add to the x's, we shift the graph left and right. Okay, so here we did x plus 2. So if you compare it to this first graph here, I'm just going to number it, graph 1, graph 2, graph 3. So if we compare it to the first graph, we can see that it has shifted 2 units to the left. And that's because we added 2 to the x's. So if we add to the x's, that's the horizontal shift. If we subtract or add from the complete exponent from 2 to the x, don't get confused, okay? So this is not the y-intercept. For the exponential graph, this is not the y-intercept. We're so used to the straight line and the parabola thinking that that constant number is always the y-intercept, but it's a different story for each graph. So for hyperbola, it's different. For an exponential graph, it's different. So this actually indicates your asymptote, and it also shows how the graph has been shifted up or down. So it's the graph of 2 to the power of x shifted down 4 units. Okay, so that's in terms of the shifts and the up and down and the shape of the graph. Let's have a look at the asymptotes and all the rest of it. Okay, so the shift we have looked at, so that's just the base. So if the base is greater than 1, the graph is increasing. If it's smaller than 1, or if it's a fraction, it is a decreasing graph. The Q, apart from it being the vertical shift up and down, it is also your horizontal asymptote. Okay, so the exponential graph only has one asymptote, and that is the horizontal asymptote. Don't get confused to think that this is an asymptote. Okay, that just shows a shift left or right. It doesn't indicate another horizontal asymptote. It is just the shift. So the Q value, that constant value, that indicates our asymptote. Okay, so let's see, let's sketch this. Let's practice a bit of sketching of the exponential graph. Just going to make this a bit bigger. Okay, so the exponential graph, in my mind, is actually the easiest one, I think, because it only has the one asymptote, and the shape can either just be going down or going up, and your x and your y intercepts, you make y equal to 0 to get your x-intercept, and x equal to 0 to get your y-intercept, which is old news because we've been doing that since grade 9 to find x and y-intercepts. And then all you have to do in addition is plot 2 points to sketch the graph. Okay, so let's start the whole process. And I'm going to draw my Cartesian plane, and I want you to draw a Cartesian plane as well. And let's look at our graph, at our equation. So here is 2 to the x plus 1 plus 1. So this is the graph of 2 to the power of x, shifted 1 unit up and 1 unit to the left. So our asymptote is going to be at y equal to 1. So I'm going to put that here. Our horizontal asymptote is y equal to 1. So let's draw that. And remember, your asymptote is always a dotted line. Clearly label it. As I was saying on Tuesday, it would be such a shame if you go through all this work and all this thinking, and then you don't label your points, the important points on your axes, and then you don't get any marks for it. That's unfortunately how it is. So label, 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 label everything. X-intercepts, y-intercepts, asymptotes, points, everything, label it, indicate what it is. Okay, that's our asymptote. Now we determine the shape. So we can see that 2 is greater than 1, so it is going to be a plane taking off. It is going to be that shape, the increasing exponential graph. Now we have to find the x and the y-intercepts. So we go through the same process to find x-intercepts and y-intercepts. It might be slightly more complicated because this is an exponential, but let's see. Y-intercept, x is equal to 0. So we take our equation and put it equal to 0. 2 to the power of x plus 1 plus 1.
Remember, we're calculating for y, so y is equal to 2 to the power of 0 plus 1. We're calculating for the y-intercept.
Yes, so we're calculating the y-intercept, so we must make x equal to 0. I made the y equal to 0. Thanks, Miss Coco.
No problem.
Let's fix that quickly. Okay, so then we get 2 to the power of 1 plus 1, and then y is equal to 3. And that makes sense, right? Because we have taken the graph of 2 to the power of x and we have shifted it up. And we have shifted it that to the left. So it makes sense that we now have a different y-intercept. Okay, so the x-intercept, now we make y equal to 0. I couldn't do this without you, Miss Coco. Definitely not.
I'll hold this whole team together. I know.
It's not even a joke. Okay, and then we see what happens here. Can we get minus 1 is equal to 2 to the x plus 1? Does that make sense? No, that's got no solution. First of all, if we just think about it a little bit logically, without spending too much time on it, a power, 2 to some power, if you think of it, if it's 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, it's just always going to get bigger and bigger positively. It's not possible that we'll have 2 to the power of something equal to a negative number. So that means no solution. So that means our graph does not go through the x-axis. And it makes sense kind of, right? Because if we think about it, the graph, and I'm just going to kind of go draw this first. If that's my graph increasing, and there's a horizontal asymptote, which is like a boundary line, it can't cross that boundary line, then it makes sense that our graph is not going to cut the x-axis, and that we get this weird funny thing, -1 is 2 to the x plus 1, that we can't solve for, because it simply means it doesn't exist. Okay, so that is it. We've got our y-intercept, our asymptote. Now all that's left to do is to plot 2 points, 2 other points. Now, I want you to calculate your own points, okay? It's going to be up to you in the exam to decide what your x-coordinate is going to be that you are going to use, and then to calculate your y-coordinate that goes with it, okay? It is, it's completely up to you. The examiner or the paper is not going to instruct you which 2 points, okay? You must know that you must calculate 2 points and choose your own x values. So I'm going to choose x equal to, I don't know, Ms. Coco, what should we use? X equal to 1 and x equal to -1. Let's do that. Let's see what we get. So if x is equal to 1, my y will be 2 to the power of 1 plus 1 plus 1. So that's going to be 2 squared plus 1, and that is 5. Okay, so then you go to your graph and you more or less say, okay, x 1 on the x-axis is about here, and then 5 will be about there. Important point is though that you label. It doesn't have to be to scale as long as you label everything. Now, if x is -1, then y is going to be 2 to the -1 plus 1 plus 1. And that is going to be 2 to the 0 plus 1. So y is going to be 2. So -1 and 2. And that's it for your exponential graph for sketching. Okay, let's see. We have a question from Mafila. Hi, Mafila. Go ahead, unmute yourself, and you can ask.
I'm sorry, I would like to ask, you said -1 is equal to 2 to the power of x plus 1. Then you said no solution. Can you please re-explain?
You're talking about this here?
Yes.
Yeah, we can't solve for that because if you think about it logically, so say we go 2 and say that x is a 2 plus 1, and what do I get? I get 2 to the power of 3, that's going to be 8. There isn't a value for x that I can put in there that's going to give me -1. It's just not possible because it's a power. An exponent always goes bigger and bigger and bigger, and this is 2 to the power. You'll never get it to a negative number. That's why there's no solution. Right, so that's drawing. I hope you've noted down. That's exactly the steps we are going to follow to draw each time we draw a exponential graph. Let's now have a look at finding the equation of an exponential graph. Okay, so just like before, you have to start by recognizing the graph for being an exponential graph. How do we do that? We recognize it by its shape. We recognize it by the fact that it's got this one asymptote. The only graph with two asymptotes is the hyperbola. We also recognize it if the examiner is kind enough to give us the equation. Then we can recognize it by the fact that x is in the exponent. Right. So that's the first thing to do, is to recognize the graph that you are dealing with. Okay, so this is an exponential graph. So we're going to start by substituting in the asymptote. Then we substitute in another point, and then we simplify our final equation. So here we have y equal to b to the x plus 1 plus q. Okay, so we start by putting in our asymptote. Our asymptote is over here, y equals to minus 2. So we're going to sub that in. B to the power of x plus 1. Just one thing at a time, guys. You just do one thing at a time. Sub in the asymptote. That's the first thing we do. Now we're going to sub in, because we still have the b to solve for. We're going to sub in the other point. So that's my point over here. So y is y is 2. And then b and x is minus 3. That we sub in, plus 1. And my asymptote is minus 2. Okay, let's simplify that a little bit. That's going to be b to the minus 2. And that is minus 2. Okay, I want my b to the minus 2 by itself. So I'm going to take the minus 2 over to the other side. That's going to be 4. Okay, I'm just going to carry on this side. Okay, let's now, as our next step, make 4 2 squared. And to get this b on its own, I'm going to raise this to the power of -1/2. I just do the opposite, because this is to the power of -2. So if you raise it to the power of -1/2, that's actually going to give you a b to the power of 1. And you do the same on this side. Okay, there's a few ways that you can do this, but this is the way that I think makes a lot of sense, because we want the b. We want b to the power of 1. How do we get that? We need to get that power of -2 to be a 1. And to do that, we can apply this rule here, where we take it to the power of -1/2. Because what happens now is you multiply these two together. -1/2 times -2 is going to give you 1. And then over here, 2 to the power 2 times, if you times that together, 2 times -1/2 is going to give you -1. And 2 to the power of -1 is the same as 1/2, so b is 1/2. And if we look back to our graph, that makes a lot of sense, because it is a decreasing exponential graph. It is a plane landing. It's in that shape, follows that path. So it makes sense that b is actually 1/2. So now that you've simplified it, now let's write our full equation out. And that's going to be 1/2 to the power of x plus 1 minus 2. Okay, Mafila has his hand up again. Let's hear.
Sorry to bother you again.
No problem.
On 2 to the power of 2, if it was another number, let's say it will be 8, you will still use that by multiplying that -1/2. Let's say maybe it was 2 to the power of 6 is equal to b to the power of -2.
Yes. The point is that Yeah, the point is that we want this. We want b to the power of 1 because we want to solve for b. We want b by itself. We don't want b to the power of -2. So how can we manipulate and maneuver our equation to make it b to the power of 1 instead of b to the power of -2? So you would do the same. But what I do on one side, I must do on the other side as well, because it's an equation. So in this instance, this hypothetical example we're just making up here, we get that. And then that is 1/8 is equal to b. Happy? Good. Okay. Right, any other questions? Can I see in the chat? Just give me a thumbs up or a thumbs down. How are you feeling about the exponential graph so far? Thumbs up. Kolofelo is also giving us a thumbs up. Good stuff. Excellent. Anyway, let's hear from the rest of you guys. We only have a few thumbs up. Is everyone else feeling a thumbs down? No, Belinda, you absolutely perfect. If you can use logarithms and you know how to use logarithms, you can do it that way as well. Well done. Okay, awesome. So let's get on to the grown-up stuff then. Let's solve and look at some questions from past papers. And this one is from March 2015. It's a hyperbola question. Let's see. We do have quiz night tonight. So Ms. Coco, what time do you think we should start the quiz? 10 to?
Yeah, I think we can take about 12 minutes and then I'm going to take over. Okay.
Okay, well, that's perfect actually, because this is 13 more questions. So
13 minutes, yeah.
13 minutes, got down to 12. Mr. Timothy can't find my thumbs button. You can just use an emoji, it's fine. But I know there's like a whole string of emojis. Okay, but anyway, I'm going to keep quiet and I'm going to give you a chance to have a look at this question from March 2015. See how you go. I think just keep working and I'm going to call time in about 3 minutes or so. We'll see how far everyone got and then we'll discuss our answers. I'll call for answers in about 3 minutes time. Okay, let's see some answers. I'm going to go one by one. For question 4.1, the equations of the asymptotes. Please put your answers in the chat. The equations of the asymptotes for question 4.1. We have an x and a y asymptotes. -2, y is equal to -1. Yes. Good stuff. Good stuff. Yes, I agree. X equal to -2 is your vertical asymptote, and y equal to -1 is your horizontal asymptote. Well done, everybody. That's really good. Okay. Now for our y-intercept of G, let's see some answers as well. The y-intercept of G. For the y-intercept, we have to make x equal to 0. Okay, so we make x 0, and then we get 6 divided by 2 is 3, -1. Y is 2. The y-intercept is 2, or 0 and 2. Well done to everyone being so precise about it. It's really good. 0 and 2, well done. Our x-intercept, let's see. Oh, people are putting the x-intercepts in already as well. So for our x-intercept, our y is equal to 0. So 6 over x plus 2 minus 1. That gives me 1 over x plus 2. We cross multiply. X plus 2 is equal to 6. Yes, lots of you getting 4, and that's marvelous. X is equal to 4. Well done. Or in proper coordinate form, 4 and 0. Excellent. You guys are doing so well. Okay, so now we're going to sketch. Sure, if this was March 2015, you guys would have been on fire. Definitely racing through this question. No problems here. Okay, so we make our, and I hope everyone is getting the sketch right, because I really, really want you to get full marks for this. Okay, so our asymptotes are at x equal to -2. Okay, so if you sketched, make sure you labeled. And if you labeled, you can give yourself a tick for that vertical asymptote. Then for the horizontal asymptote, that is x equal to, y equal to -1. Label, -1. And our graph goes, which quadrants? Our shape. That's all the stuff we did on Tuesday. So our shape is in the first and the third quadrant. So our graph goes through the y-axis at 2 and the x-axis at 4. So it's going to look something like that. I could probably have made it curve a little bit more. And like that. Okay, so ticks for your asymptotes, for your shape and your correct quadrants. And, oh, Ms. Barnard forgot to label her axes.
Label, ma'am, label. Yeah, don't forget.
You see now, there, I was on my way to full marks and I messed it up. Okay, and for your x and your y intercept. Okay. Oh, it's only 3 marks. Okay, so they probably only give 1 mark. Okay, they probably do it like this. They probably give a combined mark for asymptotes and a combined mark for x-intercepts. Okay, so you have to have both. Oh, it's tough, eh? It's tough. You have to have both asymptotes and both intercepts to get that 1 mark. They do also give you marks for that working out, so that's good. So 4.4 is probably the last one we're going to have time for. the equation of the line of symmetry that has a negative gradient in the form y equal to. So on Tuesday, if you can remember, we went through the lines of symmetry. There's either one with a positive gradient of 1 or a negative 1 gradient. So to do the negative gradient, it will be y equals minus x plus c, and we sub in that point. I wonder if you can remember what that point was. This point here where the two asymptotes intersect, because the axes of symmetry are always going to go through there. So that's minus 2 and minus 1. Oh, look at that. Y is equal to minus 1 minus 2 plus c. Yeah, be careful, guys, that you do this accurately. Minus 1 is 2 plus c. Your x is minus 2, your y is minus 1. And because it is the negative gradient, the line with the negative gradient, that's going to be a positive 2, and we subtract it, and then we get minus 3. And I see a few of you have put that down. Remember to end it off nicely. Put it all together, minus x minus 3. Okay, so let's see how we did. So if you got both your asymptotes right, so asymptote, asymptote, that's 2 marks. If you got your y-intercept right, that's just 1 mark. And then if you got your x-intercept right, subbing in, solving for x equal to 4, that's 2 marks. Your sketch, allocate your marks for your x and y intercept, that's 1 mark. Both your asymptotes is another mark, and then drawing a hyperbola in the correct quadrants, that's another mark. And that's for 3. And then to get your axis of symmetry, for subbing in, for solving, for C, and your final answer, that's 3. So let's see, you can give yourself a mark. 2 plus 1 is 3, plus
11.
5. Okay.
Out of 11, because we didn't do question 4.5. So we can like...
I can't do this without you, Ms. Coco. I mean, I'd be lost. It's it out of 11. Give yourself a mark out of 11, and if you want to share in the chat, let us know how you did. But I have a feeling you guys did very well with this, and if this was March 2015, you would have killed it.
On fire tonight. You guys were doing the things.
Well done. And yeah, I mean, we do have the last question as well, more of a problem-solving complex question, okay? But do you guys see, you don't have to stress so much about those questions, because if you just know your work, you can get 11 out of 11. There you go. Nkolise, point proven. Okay, dear. Luckily, next time, you know. Okay, Ms. Coco, I think it's time for us to leave it there. Does no one else want to share? Oh, more. Yes, excellent. Well done.
This is awesome.
Well done. Well, then you're definitely going to nail the quiz as well. Excellent, everybody. And this is an actual past paper question. So well done to all of you. Okay, over to you, Ms. Coco.
Honestly, guys, I had no doubt. I knew you guys were going to get it all right, because you guys have been listening, which is awesome. All right, guys, I'm going to pop the link to the quiz in the chat now. You are more than welcome to do the quiz now if you'd like. You don't have to stay online to do it. You can just click on the link, or if the link doesn't work for you, just log back into watobe.co.za and you can take the quiz from there. Remember, again, guys, it's a low stress quiz. Just zen, breathe. There's no need to be like, don't stress yourselves out. You can take it more than once if you need to. It's more for your understanding. Okay, but with that said, that is it from us for tonight. we are going to see you guys again on Tuesday, same time, same place.
And then we do November 2016. There we go. I've got it lined up for us already. November 2016 exponential graph.